Hello, everyone. My name's Peter Hughes. I'm the head of cloud here at Push Technology. So thank you all for joining. Today's session is going to be a high-level introduction to Diffusion Cloud, really talking through what it is that we have with our platform and how to use it for building and architecting real-time applications. I know there's a whole bunch of different industries and use cases that we find our customers bringing to the table. So what I'm trying to do with today's session is really give a pretty broad view on all the different ways that Diffusion Cloud can help with architecting and developing different types of real-time functionality, and a few of the features that we add on top of that to make things a lot easier than you might otherwise find them. And with me today is our co-host, Abhishek Ahmed. He'll be running backstage here to answer any questions that you might have or flag up to me to stop if I'm going too fast. So big thumbs up to Abhishek for stepping in as well today. Okay, so without further ado, I'll start running through things. So to kind of begin, I want to take a look at what real-time over the internet really means and why it's important. I think there's sort of three key sort of trends that have been emerging over the past couple of years that are really what we're trying to solve at Push Technology. So the first is just a growing demand for real-time applications. We're seeing more and more web and mobile and IoT applications that are trying to become more interactive, support multi-user experiences, multiple devices, applications that are bringing together a whole bunch of different front-end technologies in order to deliver more compelling experiences to the consumer market. The second trend is really about how more and more organizations are trying to turn existing APIs that might be more traditionally REST-oriented into something that can support real-time behavior. So being able to extend and enhance existing data sources and interfaces in a way that will support both today's and the future's reality of kind of real-time data consumption. And the third major trend is the rise in event-driven architectures. We see this as microservices becomes the predominant pattern for architecting back-end infrastructure, and event streaming across services and regions and even ecosystems is becoming more and more important. And of course, when you're streaming across services and regions and different ecosystems and platforms, you're having to communicate across shared architecture, namely the internet. So all of these trends in how we're moving and consuming data are driving a growth in the need for real-time solutions, but also kind of exposes some of the limitations with existing technology. So if we look at what a general technology stack might look like for an application, we need some kind of data store. Traditional databases obviously are built to handle the volume of data. And so when we look at databases, Postgres, Redis, MySQL, they're all very good solutions for large volumes of data sets. When we take a look at user-facing apps in a B2C world where you may have any number of thousands of users, and each user might be running your application on mobile devices, laptops, desktops, we now have a plethora of connections on top of that data. And when we add real-time to the mix, we now have to deal not with the volume of data, but a volume of events, of changes to that data. And the flip side of this, and something that has always sort of existed, but a lot of traditional technologies tend to ignore, is that with real-time, we now have a requirement on latency, how quickly we can access data, how quickly it takes between something changing in the back end and a user being notified of that change. So any technology solution that you're trying to use for a real-time application needs to be able to deal with these new requirements, as well as satisfying the existing ones of data volume and connections. So with Diffusion, we have a platform that we've purpose-built over the past decade to solve exactly these kinds of challenges. We have customers running across a whole variety of different industries and use cases, but they all need to handle the same core responsibilities: moving real-time data at scale and quickly over the internet, while at the same time being able to handle both sophisticated application architectures and models, and also securing data. And that security needs to be both in terms of authentication, but also authorization, who people are and what they're allowed to access. One of the common types of requirements or questions that we often get is, why can't we just do something with WebSockets? Or why can't we just build something on top of REST? With WebSockets, we find that, yes, it's a streaming transport, but it doesn't provide any of these higher level functionalities or capabilities. How you define data access or security is entirely incumbent on you. And with RESTful interfaces, we often find that while they may be able to scale perfectly well when you're dealing with stateless kind of poll-based architectures, as you try and increase the volume of events that are flowing through a system, as you have more connections all trying to access data at a quicker and quicker rate, those types of interfaces just simply can't scale. You need something that's purpose-built. So that's why we have Diffusion to satisfy those needs. I'm going to pause right here. I see that someone raised their hand. So Abshir, is there a question to answer?
No question right now, but we can allow Oliver to talk if he wishes and asks away.
Oh, hello. Yes, I was on mute. I don't have any questions. I'm just watching at the moment.
Okay, perfect. Well, if at any time you or anybody else does have a question, then please raise your hand, chat away, or we can answer your question as and when they come up. Okay. Anyway, moving on. So there's four fundamental parts of Diffusion that really help satisfy these kind of requirements that I've been discussing. I think the major one that's really at the heart of Diffusion is the way that we combine both pub/sub event distribution with an event cache, a key value store that's able to hold on to the values of particular events. And these two components combined together allow us to store and access real-time data in a structured way. And that structure is really what's at the heart of facilitating some of the more sophisticated uses of Diffusion and applications. And one example of that is real-time processing. So Diffusion offers not just data delivery, but the ability to take in-flight events and process them to change the structure and values in a way that enables you to start integrating different types of applications and data sources more easily. One of the other common requirements that we see from users is pushing data out in a pub/sub mechanism is great for a broadcast type workflow. but sometimes you need to be able to communicate between different services or parts of an application. So we also have a real-time RPC facility in Diffusion, allowing you to send messages between different services and connections in order to evoke more complex or sophisticated application logic. And finally, we have a global security layer, letting you define access control policies at every level across data access and connections. So I want to take a look at PubSub and Event Cache and walk through each of these features in turn. But I think it's best done as part of a demo. So I'm going to show you Diffusion Cloud. This is our new dashboard that we have available. You can access it at dashboard.diffusion.cloud today, sign up and start using it. And I'm going to open up a service that I've created earlier. Now we have a variety of different ways that you can start pushing data into Diffusion. Today I'm going to take a look at our REST API. So this is an API that allows us to start pushing data into Diffusion Cloud from any application. I'm going to take our bearer token. This is the unique security ID that we have for my service. And I'm going to put this into a Python client that I've written beforehand. What this Python script is going to do is run through a set of predefined sensors. We're going to authenticate with our REST API, and then we're going to begin updating different items in Diffusion Cloud with random data on a periodic basis every second. So I've given us our unique ID. I'm now going to start up our script. And of course, it's going to not quite work as expected. So I'm going to move to our backup plan, which is the same script, but in JavaScript. By taking our hostname and putting that into our JavaScript SDK, I can begin running exactly the same logic of connecting to Diffusion through our JavaScript SDK, and then updating topics every 200 milliseconds. And in typical demo fashion, it's not working either. So give me 1 sec to fix the typo. And there we go. We have data flowing into Diffusion. So taking a look at that data is just as easy. If I subscribe to our topics within the Diffusion dashboard, I can see that we now have random data being generated on a constant flowing basis. And this is being sent into Diffusion from my local machine. Now, Diffusion runs in the cloud. We provision a bespoke isolated service for every user. So this data is entirely mine. It's entirely private. It's not being held on any shared infrastructure. So from a security perspective, you're guaranteed to be able to control access to this on a completely individual basis according to your particular business needs. And this data is being distributed in a PubSub fashion. So I'm pushing data from my source application, and I can now subscribe to that from any number of different consumers. Diffusion is purpose-built to be able to scale for these types of user-facing applications. Services or products like Kafka, for instance, offer topic-based event delivery, but in a way that's built for inside the data center. They're designed for large volumes of data, but not high volumes of connections. Diffusion, on the other hand, is built for both high volumes of data. We have customers with millions of unique data items being published every second, but we're also built for high volumes of connections. We can handle tens or hundreds of thousands of concurrent connections at the same time. And that's all in order to be able to provide a real-time application that isn't just for inside the data center, but is something that can be really built into user-facing apps. Just to review what the benefits of this sort of pub-sub model looks like and why this is useful for those who aren't familiar. What we have, or what I've just demonstrated, is having multiple backend services broadcasting data into Diffusion. If my source code didn't have a typo in it, we would have had both REST and our JavaScript SDK pushing into Diffusion. And then from the front end, we now have the ability to select what kind of data we want for that particular application. I demonstrated subscribing to all of those sensor values that are being streamed, but I could just as easily subscribe to just a single one. This kind of shared data model as part of the pub-sub model enables you to have decoupling of your backend components and services from your front-end components and services. It lets you start adding and moving around your data sets entirely at will. And of course, the other side of this too is the API layer that provides an event cache. So it's not just about pushing data through Diffusion. It's about how Diffusion can hold on to these events, let you query and poll them. If, for instance, you may have some part of your application model that needs to store user profiles. You can use Diffusion to stream out changes to profile data as and when it occurs. But Diffusion can also act as a cache for that profile data, letting an application just query it if you need access on a more on-demand basis. Similarly, using our time series functionality, you can keep a history of data. You can fetch events that were distributed days ago if you so desire, if that's what you need. You can architect things like chat messages really easily using pub-sub for providing the live updates, and then time series and fetch queries in order to retrieve historic values on demand. As an example of that, I want to go back to our Diffusion Cloud profile. And here in our Getting Started page, there's just a few example snippets. So here I'm going to just choose the topics I'm generating my data on. If I take a look at this, it's under the path data, sensors, and ID. So I'm going to do data sensors 11. That's now being brought up here as it changes. But if I stop this data source, copy this example to the clipboard, and paste it into my terminal, the authorization token takes a little time to paste. I can now see that we've got a response back where we've queried against the Diffusion Cloud REST API, and you can see that I have the JSON payload returned with the value, the ID, and the name of Jasmine. So that is the high-level overview of Diffusion operating as both a pub-sub broker or event broker, but also an event cache. the ability to not just move data, but also to store it. And what this really means is that with Diffusion, you can now interact with data in a way that's most appropriate for you and your applications. When you need live updates, you can get those. But because there's this single consistent data model behind all of it, you can also treat it as a historic data set when that makes more sense. Because we're using a pub/sub model, we're decoupling the consumption side from the production side, which means that you can scale up your backend services independently of the number of front-end consumers. In Diffusion Cloud, we're distributing billions of messages every month on behalf of our various customers. And that type of scale is something that we are innately designed for. And finally, from an integration perspective, we have both SDKs and a REST API, as well as adapters for Kafka and other systems. So you can start pulling in data from wherever it currently sits and really start building up prototypes and applications with minimal development time. That time to market is really important. So the next thing that I want to kind of cover is the event transformation part. Unlike other systems or more traditional messaging systems, Diffusion has the ability to actually transform data in flight. So as events are pushed into the system, you can group them, expand them, you can format the values by picking out specific subsets, or you could throttle and conflate. You can control the delivery parameters of those events. And this is a system that has been evolving in the product over the past year or two. We're continuing to expand this as we see more and more use cases. But the main motivation behind this is to make it very easy for you to bring in different disparate data sources. And instead of having to control them at source, you can now define how they should be presented to your front-end applications at the delivery layer, at the edge. We've had numerous customers who are saying that being able to actually change these, the format of the data to perform these sort of modifications on the fly means that they get to remove logic from their backend systems. They no longer need to maintain all of that. And it also helps with being able to develop new applications, be it on the backend or the front end. Because they can control and dynamically transform data, they can start developing new front-end features. And instead of having to set up all the back-end services to support those front ends, they can just take the existing data and reconfigure it into a format that works better for their new applications. So I want to take a brief demo of this functionality as well. We have our data streaming into Diffusion. So now I'm going to look at our administrative console and walk through our topic views and transformation capabilities. So as mentioned, we have our data. We have it in this tree structure, so data, sensors, and then the various IDs. And within each data item that's being updated, we have a value, we have an ID, we have a name, and we have a type. So let's try and categorize all of these sensors by their name. In topic views, we can add in a new view, which is the feature name for these kind of transformations. So I'm going to map by data, sensors, and then a wildcard selector to match any and all data items beneath that particular path. I'm going to map this to data by name. And then we're going to use a little bit of custom syntax that's going to take the name field and put it into the topic path. If I click add and go back to our topic browser, we can now see that by name has been added, and we now have all of the same data sources being presented under the name field. If I subscribe to all of these topics, you can see that they're all being updated at exactly the same rate as the original data. And if I stop this sensor, all of that data will pause as well. Now, this works exactly the same way as our existing topic pub/sub streaming, but also the fetch. So I can come in as an application and query this data on a case-by-case basis, regardless of whether it's being produced directly from source or if it's being derived from a topic view or transformation rule. And we can also do more sophisticated things. We can use topic views to group elements. If I map the same set of data, but this time I'm going to try and pull out a scalar field that's going to be shared between them, the type field. Then I'm going to present them by ID. And now I'm going to use a value mapping to just pull out the specific value field from them. Go back to the browser view and go to by type. We've now grouped individual sensors under either red or blue according to that field. And in each one, we only have the current value as opposed to the full JSON payload that's being presented from source. And of course, all of this is still being updated completely in real time. So as all of these transformations are being applied, they're being handled dynamically and on a completely ad hoc basis. You can amend, add, remove these transformation rules whenever you like, which means that you can continue to evolve your real-time data model over time. And just to walk through what I showed us here, because it can get a little complex, we have our source topic. This is the data that's being sent directly from source. In this case, my Node.js script is running on my laptop. And we have a particular JSON payload in each event. So my topic view is, first of all, mapping a particular part of our data model, data/sensors/1 for here maps to the wildcard selector in our topic view. Next, we're going to pull out a particular field from each event. In this case, the name field. And we're going to use that to construct the new namespace, the new data item or part of our data model that we want to put these transformed events into. And then finally, we're going to use the value syntax to extract a particular value from the original payload and present that as the new payload. What this means in real terms is that you can extract values on a per field basis. And when you look at combining this with security rules, it means that you can now apply completely dynamically per field security if you expose only particular subsets of your overall data model under particular transformation rules. So to summarize, in-flight processing and transformation, it means that we can meet different consumer requirements. The same data sources are now able to provide data in different formats according to different types of application needs. And all of this can be done completely dynamically. as you start evolving your architecture, be it on the back end, the front end, or even just at a business level, you can create and modify these rules to match those changing requirements. And finally, from a presentational perspective, you have the ability to take that standard global pub, sub, and event cache and start adding and developing independent apps. You may have separate teams building different types of consumers on this, and you know that you can now support each of those individual teams or applications without impacting the others by changing data at source. So the third component that I want to talk through today is real-time RPC, the ability for applications and services to talk between each other. So just as a reminder, what I've demonstrated so far with Diffusion is using our pub/sub functionality, which is moving data from a data source and then broadcasting that out so that any number of front-end consumers can receive that data. Now, real-time RPC, or request response functionality, offers a different model where individual applications or sessions can send a message to a particular receiver and get a response. Now, this is really important for being able to provide functionality like placing orders, anything that might be transactional in nature. Or potentially you could use it for asserting kind of real-time validation logic over things like chat messages, where instead of the front end being responsible for updating the shared data model, you send events directly to a backend service, which can then provide any number of auditing, analytics, or processing rules that need backend logic to perform before then pushing that back into Diffusion for general consumption. So as an example, we may have a message sender that can publish a chat message into Diffusion. And this is using the RPC functionality. It uses Diffusion to act as the communication channel for sending a RPC message with whatever chat payload it wishes to send. Diffusion then acts as the message broker. It understands that there are several remote services that have been registered to handle that particular type of message. And it basically load balances, selects one of those services to receive it, and then dispatches that message to the backend service. The backend service can then obviously handle that message however it needs to. Can send a response back to Diffusion. It may choose to respond either directly to the original sender, in which case Diffusion will be responsible for coordinating that response, making sure that the sender receives that data in the timely manner. Or the backend service could update a topic that is being subscribed to by multiple consumers, in which case those updates would just be broadcast as per normal. I did a webinar a couple of weeks ago about building real-time messaging functionality with Diffusion, where we look at exactly this type of architecture for being able to build up chat messaging in a secure and reliable manner. One of the key things behind this type of RPC functionality is that you can have multiple handlers registered for messages. Diffusion will load balance across all of them. And this means that just as you would with a RESTful interface, where you may have multiple application services behind an API layer that you can scale in order to meet front-end demand, you can do exactly the same with Diffusion, running multiple back-end services to respond to messaging requests and send responses as required. So the final section or piece of functionality that I'd like to cover today is the authentication authorization layer of Diffusion. So this is really about being able to control who can access Diffusion and once they're connected, what they're able to receive or do. So Diffusion comes out of the box with its own security store. We have inbuilt support for username and password connectivity, as well as social sign-in and Auth0 integrations. So out of the box, you can start building secure systems with Diffusion. And that works just as you might expect. Every front-end application provides a username and password or some other security token if required. Diffusion is then responsible for taking those credentials, validating them against the built-in store, and then either responding with an affirmative action, allowing that session to continue, or to fail the authentication connection, in which case you as the front-end application will be notified and can handle it accordingly. But we know that not every built-in solution is going to be fit for every customer's requirements. We have quite a few users who want to have some bespoke logic for handling their security requirements. So Diffusion also provides some pluggable authentication hooks where, just like with request response messaging and RPCs, where you could register message handlers, you can also register authentication handlers, backend services that will be notified whenever a client is trying to connect and can then respond in order to allow or deny that connection. Again, this flow is pretty straightforward and it's much similar to the previous one. Front-end application attempts to connect. Diffusion can respond immediately if those credentials are already known to it. But if Diffusion doesn't know about that user, it will then proxy that authentication request to any registered authentication handler in the backend. That handler can then approve the connection, and in doing so, it may wish to update Diffusion's built-in security store, or it could just only approve the connection in order to be able to handle every subsequent attempt if that's what you require. Or the authentication handler can deny the connection attempt. In either event, Diffusion will proxy that through down to the front end. Now, this is very useful when you want to be able to start maintaining a view over your entire connection base, your entire user base. You can obviously provide an audit trail of all connections this way, or you can provide additional multi-factor authentication rules as required. It also means that you can do things like attaching metadata to connections, which you can use with the async RPC functionality in order to send messages to any connection that's been tagged with a particular field. So by combining these pieces of functionality together, you start being able to supply quite sophisticated interaction models, not just for moving events and data, but also for handling your connections in a production architecture. And of course, once authorized, there's numerous permissions and real-time security rules that you wish to apply. And all of that is exposed through our admin console as well. So if I look at the security tab, we can go through, look at the different roles that are defined. Looking at a client role, we can control on a very granular basis what each connection with that role is allowed to do on a global level, whether they can view or modify server or sessions or security configurations. And then we can also define what they can do on a per topic basis. You can lock down certain parts of your data model so that only particular types of clients can subscribe or even see the existence of different bits of that data. And all of these security rules are applied completely dynamically. You can add and remove these permissions at any point in time, and any changes you make will be immediately applied. You don't need to wait for connections to re-authenticate before picking up any updated security roles. And that can be really important for any customer that's trying to build an application with strict security requirements, you're now able to know that any changes at an operational level will be immediately and effectively rolled out across all active connections, be that 1 or 10,000 concurrent users. So to recap, we have granular dynamic permissions. So you can apply and modify these security rules in real time at any level. We have both out-of-the-box and pluggable authentication. So you can implement bespoke authentication flows, whether that's using our existing standard username password facilities or your own custom integrations. And finally, we have access control that scales. We have customers today that are using millions of unique permission sets across different types of roles and different types of clients. And that granularity and scale is absolutely necessary if you're trying to provide an internet scale public-facing application. So we're coming up towards the end of the hour, and I'd like to summarize what we've covered as the 101 fundamentals here. So we introduced Diffusion with the pub sub and event cache, the ability to support real-time event-driven architectures by not just moving events in real time, but being able to store those and make them accessible for any types of interaction that you may require. We have the real-time processing, the ability to take these events and apply transformation rules, not just in a predefined manner, but dynamically, where you can add and evolve your information architecture over time. Beyond just standard pub sub event streaming, we also have a real-time RPC mechanism, the ability to build up responsive systems where different components in your application architecture can securely and reliably communicate between each other in order to impact or affect real-time events. And finally, the security layer, where you can control at scale both authentication and authorization across your entire application stack through Diffusion. Hopefully this has been useful. I hope you've learned a little bit more about what Diffusion is, why it's useful, and how it can help you build real-time applications. I'd highly encourage anyone who hasn't done so to sign up for free today at dashboard.diffusion.cloud. And if there are any questions in the chat, now would be a perfect time for anyone to raise their hands and start asking. In the meantime, I'd also recommend, if you want to learn more, then please check out our developer hub, developers.pushtechnology.com, where we have a whole variety of example code, tutorials, developer blog posts, and knowledge-based articles. We have a Twitter account at push_technology, where any updates around materials, product releases, and webinars will be announced. And we also have a YouTube channel at Push Technology, where we are publishing a series of various tutorial videos and other educational materials walking you through how to use Diffusion or how customers are using us in production. So we'll keep the lines open for a few more minutes in case anyone has any questions. I'd like to thank everyone who's joined for taking the time today to listen to us speak. And hopefully, even if we don't hear from you today, look forward to hearing from you in the future. Okay, if there's no other questions, then I guess we'll wrap it up. So thanks again for everyone who joined. I really appreciate your time.